24. This one was shifted right pi over 4 and down 2. So wherever your asymptotes were, for cosecant, they were at all of your multiples of pi, 0, pi, 2 pi, negative pi, negative 2 pi. So if it was shifted right pi over 4 instead of being at 0, it's now at pi over 4. Instead of being at negative pi, it's now at negative 3 pi over 4, and so on and so forth. Count the spaces in between, do another asymptote. And then the entire function was moved down 2. So usually it goes up to 1 and down to 1, but now it goes to negative 1 and negative 3. I did want to point out one thing because I was saying this wrong yesterday. When we were talking about the asymptotes and just finding them like from the table, whatever it was from the table, and adding the period, that is still partially true, except it's half of the period. So each one that we were doing yesterday should have been half of the period. So instead of, for 25, instead of negative 13 pi over 16 plus 3 pi over 4k, it should have been 3 pi over 8, okay? So it's half of whatever the actual period is. Because you have to think of, in this period, there are actually 2 asymptotes before it repeats again. So half of the period would show each asymptote. Same thing with this one. Instead of it being, I think we said over, I don't remember what we said, 2 pi over 3, it should be just pi over 3. Okay, 27, I did tables there, but I only wrote the final table up there. This one is really far off the graph. This highlighted part is supposed to be where it really is. So your asymptotes are at negative 2 pi, 2 pi. This did not help me with that a whole bunch, except I had an asymptote at negative 2 pi, and I see that it's going every 4 pi, there's another asymptote, because at negative 6 pi there would have been an asymptote. So moving forward, if I count 4 pi, there would be another asymptote. Off the graph there would have been an x-intercept. You don't see that here. And then the characteristics are off to the side. Questions about 24 or 27? Reciprocals. Yes. So the only ones that have amplitude and midlines are your sine and cosine. Yep. All right, last one. I was trying to be enthusiastic because we've been on this Stop. Yes. And the asymptotes are different. Just keep wrong. Alright, so for cotangent, we're going to use a different table because remember cotangent is the reciprocal of tangent, so it's not going to be at an asymptote the same places as tangent. So instead, we're going to start this off at 0. Still count by pi over 4s. Because tangent had a period of pi, cotangent will have a period of pi. So we still need to use some amount of pi. Now think about what cotangent's values were in comparison to, tangent in comparison to cotangent. What would the cotangent of 0 be? 0. The tangent of 0 is 0. So here it would be undefined. That means pi would also be undefined. Wait, this is the first one.
Okay, pi or okay.
Cotangent of pi over 4 would be the same as tangent of pi over 4. 1. Cotangent of pi over 2, 0, because tangent is undefined. And then cotangent of 3 pi over 4, negative 1. So when we graph this, it's going to look the opposite direction of tangent, where our asymptotes are at every multiple of pi. Remember, each line is a pi over 4, so pi over 4, 1, pi over 2, 0, 3 pi over 4, negative 1. Still has that cubic function look to it, but now it's facing the other direction. Remember, tangent usually goes to the right, goes up to the right. This is going up to the left. And then it repeats itself. That's what would the amplitude of this be? None. Still. Period. Pi. From start to end, or in between my asymptotes. Domain is going to be wherever your asymptotes aren't. It's not where your asymptotes are. So this is at every multiple of pi. Your range. All real numbers. In this case, you have x-intercepts at every multiple of pi over 2. Sorry, every odd multiple of pi over 2. You don't have a y-intercept because of your asymptotes. And then you wouldn't have a midline also. The x-intercept. This is pi over 2.
Oh, sorry.
Negative pi over 2. Alright, so we're going to do one of these examples. You're going to do the other. Both of these are not difficult. One can be done without the table, the other one just stretches it.
Did it stretch one?
Okay. That's good, because that was the one I was going to do. So notice that this one has a number by x, so we have to factor that out. Remember, anytime you factor these out, you're dividing. So negative 2 pi divided by 1/2 would be negative 4 pi. I said we're factoring out this 1/2, so if we're dividing negative 2 pi by 1/2, it would be what is our phase shift? Right 4 pi. And our vertical shift, up 4. You just put that on my notes. Alright, so because it was stretched, I did use a table just to kind of help me see where it ended up. Right? So we're using the table we just wrote down. 0, pi over 4, pi over 2, 3 pi over 4, pi. Where 0 and pi are undefined. Yes.
How did you get the pi, or did you multiply it by 2?
Divided it by 1/2, so multiplied it by 2, yes.
Oh!
Both sides by 2. Instead of having like rows.
So I wouldn't start doing that, because then it's going to change the entire problem. You just have to factor out this number.
Alright, sorry.
I'm also going to say always divide, because if you always multiply, that's going to change it also. This one happened to be multiplication because it was a fraction. Sometimes you'll have just a fraction. 1, 0, -1. Alright. We are multiplying our x's by what?
2.
2. The reciprocal. And then our y's we're multiplying by -1/2. Right? So this becomes 0, pi over 2, pi, 6 pi over 4, 3 pi over 2, and 2 pi. And then for your y's, undefined stays undefined. This becomes -1/2, 0, 1/2. And then we are adding 4 pi to our x's and adding 4 to our y's. So plus 4 pi to x, plus 4 to y, to x, and plus 4 to y.
Plus 4 to x?
To y. Plus 4 pi.
Oh yeah, 4 pi.
So think about these as it's a half. So if I add a half to 4, I get 4.5. 3 halves is 1.5. So if I add 1.5 plus 4, I get 5.5. What's it for?
It's 4 pi and 4 pi over 2.
This is a 9.
What's it, 9?
Yes. 9 pi over 2 is 4.5. Yes.
What was the transformation for the second table?
Add 4 pi to your x's. Add 4 to your y's.
Add 4 pi
To your y's. What did it say? 5.5.
2 times 8.
Wow. 2 times 8. That's 16.
So undefined stays undefined. And then we are adding 4 to -1/2, so 3.5. 4 and adding 4 to 1.5. 9 halves or 4.5. Now, none of these points are actually on your table or on your graph, but we can find the patterns. Every 2 pi, there's an asymptote. So that means if I go back 2 more pi, there'd be an asymptote. Back 2 more, asymptote, asymptote. Because this is going to repeat itself, I can follow these 3 backwards. So at 3 pi, I'm back here. sorry. 4 pi, 3 pi, I'd be here at 4.5. 2 pi, or I'm sorry, 3.5. I'm doing this backwards. I went back too much. Sorry, I'm starting over. 4 pi, 3.5. 3 pi, 2.5. 2 pi. 1.5. So that'd be 3 pi over 2. Would be at 4.5. Pi, or 1, I'm just counting backwards. 1 would be at 4. Half would be at 3.5. 0 would be undefined. I just counted backwards. Counted backwards by a half. So start at 6 and do minus half. Because you're looking at me confused. Start at 6, start subtracting a half. Until you get the numbers that are actually on our table. That's all we were doing. We're just going backwards. The pattern repeats itself. Yes. Okay, so ask me that in 1 second. Now, in this case, it was reflected, so it's no longer going the direction it should have been. Ladies, please be quiet. I was talking to them, not you guys. And then it's going to repeat itself once more. So dead in the center of your asymptotes should be at 4. 2 over should be up to 4.5. 2 left should be down to 3.5.
So it's not, it's going in the same direction.
As tangent because it was reflected, yes. So sometimes your tangent and cotangent will look like each other. Just like secant and cosecant. Now do we have questions? Okay. You have one more example. I want you to try that example. I can say that one can be done without a table, but you can use your table if you would like. And then I just have to talk to you about one more thing. One thing that I saw on the study guide.
Oh my God.
For 28, your graph should have looked like this. Alright, your asymptotes are have been condensed. So it was at 0 and pi and 2 pi, but now it's at every pi over 2. Even though it was shifted left, right 3 pi over 2, it still ends up being at 0 pi or 0 pi over 2 pi. So it's at every.
I have a question.
Yes.
Is your period in your asymptote just like K?
In this case.
But in the left, the other one too.
That's not always the case. Sometimes it's half of that. Questions on this one? Okay, so if you have not looked at Edmodo to see the changes and fixes on the quarter test study guide, make sure you do that. Also, I just wanted to point out a couple of things. There were a couple of things that I saw that I just want to make sure that you were aware of because we didn't necessarily do this in class. but this is not something that should be new to you because you did it in geometry. But for this one,
Oh, let me check my answers.
this one was asking you to find the angle and not your sides. So when it gives you your angle and when it doesn't give you your angle, you're looking for the angle, which means you need to find your angle. Set it up the same way that you would anything else, except because you're looking for your angle and you have to solve for it, in your calculator you have to take the inverse.
What do you call?
So right above sine, cosine, and tangent, there are inverse buttons. And when you do this, it needs to be in degrees. So you would hit second, cosine, put that fraction in, and you would get your degree. So that's the only difference. I just wanted to make sure you were aware of.
What do you call variable?
I did it all right.
Tomorrow morning is your last chance to ask questions before the test. We're going to start the test tomorrow. And if we need to, finish Friday.